Dear all, welcome back. All right, let's begin with our memory and context management. Awesome. Oh, let's get this ransom base out of the way. So, memory is just saved notes about the current task or past interactions. Let's delve in a little bit deeper. The idea behind the memory that works on agents is keep context across turns. The plain idea, without memory, every message is isolated. With memory, the system carries forward the key facts. Why does it matter? Because fewer repeat questions and faster answers. Here's a simple example. In a support chat, the agent stores order ID, A1234. Next message, it can continue with that same order instead of asking again. Number two, to be consistent and to reduce re-entry. The plain idea here is memory lets the system reuse stable preferences or details. Why does it matter? Results now feel predictable and the setup time drops. Simple example, if a user prefers email updates, the system automatically picks emails next time instead of asking for a channel. Another big reason memory and context management is crucial is to adapt and to personalize within limits. The idea is over time, stored context can guide minor adjustments. Why does it matter? Suggestions fit the user better and common steps get streamlined. An example would be a study helper notes which topic a student already mastered and suggests practice on weaker areas first. Gosh, as a professor, can't tell you how useful that would be for my students. Techniques for effective memory management in agentic AI. Short-term versus long-term. So, what is it? Short-term session memory. It's temporary notes for all these conversation tasks, recent questions. For example, the current order ID. Long-term memory would be the saved settings or facts that last across sessions. User preferences, frequently asked questions, policy snippets. Why does it matter? Short-term memory keeps the current flow smooth. Long-term avoids re-entering the same info every time. An example, in a support chat, short-term memory keeps order ID A123 during today's conversation. Long-term memory stores that the user prefers email updates for the next time. Yes, vector databases and meaning search, not technique here for memory management. What is it? Turn text into numbers, vectors, so the system can find similar meaning, not just exact words. The vector space. Remember the cosine similarity, dot product matrix? Why it matters? It retrieves a helpful content even when people use different wording. Money back versus refund. Example, a bot asked about returning shoes. Steve finds the policy that says refund on footwear because the meaning matches. It's really, these are the challenges of the NLP that bear fruit here with the agent and Gen AI. It's not just the syntax, it's the semantic. It's not just the syntactic, but the semantic. What does it mean? And harder, even pragmatics, innuendos, sarcasm. Memory techniques continue. There's more to it. Chunking on context video. Chunking, it's LangChain. That's what does the chunking for us. Split longer contents, doc transcripts into smaller pieces, chunks that fit within the model's reading limit. You can change that. In one of our exercises, we have an opportunity to change that. The size of the chunk, how the overlap of it. Why it matters? The system won't lose track or run out of space. It can focus on the most relevant parts. For example, a 50-page PDF is split into 500-word chunks. The system pulls only the 3 to 5 chunks most related to the user's question. Metadata and tagging. What it is, in simple term, add labels like time, author, product, or topic to each chunk. Metadata, the meaning behind the meaning, the data behind the data. Why it matters? Filters make search fast and accurate. Latest, category shipping, region is US. These are the filters that are making the response accurate and faster. Example, when asked for current refund rules, the system filters on region, US, and the newest timestamp for answering. It's fascinating. There's always a trade-off between speed and accuracy. More data, less privacy. RAG. At the end of this, we have a wonderful Python exercise using RAG and chunking. We'll do it together. Why it matters? Look up first and then answer. The system fetches relevant chunks from its knowledge store and uses them to craft the reply. Example, what's our holiday return policy? System searches the policy docs, grabs the right section, then answers with that info and can cite it. So how does the agent connect with external tools? That, my dear, is the story of MCP, Model Context Protocol. Imagine you're building a robot assistant. Without MCP, you'd need to write custom code for every single thing it needs to access. Your calendar, your files, your database, your email, etc. Each one would work differently, such as having dozens of different chargers for various devices. MCP, think of it as the USB-C port, right there, for all agents. So my Mac in here has the C port. My phone also has the C port. One standard connection, the earpods now, one standard connection protocol that works with everything. Even my Chromebook over there has a C port. Think of MCP as a universal adapter that enables AI agents to connect to various tools and data sources in a standardized manner. You might even argue that MCP might append APIs at some point. Instead of building separate integrations for each one, MCP provides a common language. You create MCP servers, is what we do create, and think of them as plugins that exposes these capabilities, and your AI agent now can connect to them using various protocols. Let's go through this flow in here. So, an agentic flow with MCP. Number one, user request. Schedules a meeting and sends the agent from my files. That moves on to the LLM, large language model. Analyzes request and plans steps. Needs to access calendar. Needs to read files. And it needs to send that information. Let's move down. The MCP now comes into play and says, okay, I'm a standardized tool discovery. I can have united function calls, and I'm consistent with data formats. That is now connecting to my the MCP server to the calendar, the MCP server to the database, to my file system, web search, any tool that you have. And now it's time for action. It's one thing to talk, it's another thing to do. Calendar accessed and meetings scheduled. Files read and agenda retrieved. Information sent to the participants and the user response. And this can go in an iteration. A key point in here, I like this. MCP sits between the AI agent and the tools. Well, you're seeing that yellow part down here. Without it, the agent would need custom code for each tool. With MCP, the agent uses one standard protocol to talk to all tools. Great URL. We have this also in the notes below. And this one is official GitHub organization with all MCP repositories where you can download and start building a server, MCP server. Now, evaluating your agent. How well does it work? Why measuring matters? Don't judge an agent by a single metric. Check several things. Accuracy. Are the answers right? Speed. How fast? There's a trade-off here. Accuracy and speed typically are in a constant battle. Reliability, does it work every time? Adaptability, can it handle new cases? Costs, how much does it cost? Compute cost. Why it matters? This ensures the agent helps in real-life situations, not just on a test. An example, a help desk agent that's accurate but very slow still frustrates users. Being fast but wrong is actually worse. You need both. A common challenge with agents don't behave exactly the same for every input. Can slowly get worse as data changes, entropy, and need more than one success measure. Why it matters? If you don't track these things, the agent can drift. It's got quietly getting worse, and you could miss your chance to fix it. I have a section on drift coming up. I'm going to chat about that. Quick example, a return policy bot works great before the holidays. But after policy update in January, its answer gets slightly off unless you monitor and retrain. So the 5 core dimensions, these are simple checks. Accuracy, get it right. Percent of correct answers on a small labeled test set. That's how you check it. You can set a threshold. 100 sample tickets with known good replies. Agent matches 92, so we've got a 92% accuracy there. Efficiency. How quickly does it do? What we want to check is the average time to first useful response. Total time to finish a task. An example, agent suggests the first step in less than 2 seconds, closes common tickets in under 60 seconds. We want to measure that efficiency. Reliability. Let's check for reliability. Error rate, timeouts, tool call failures, retry counts. Example, out of 1,000 calls, less than 1% fail. No more than 1 retry per task on average. Adaptability. What do we want to check? Performance on new or slightly changed inputs versus the old test set. An example, after a policy update, accuracy on refund question stays greater than 85% without manual fixes. And costs. We want to stay within budget. What do we want to check? Cost per task, API tokens, the compute, and monthly total. When we do our OpenAI exercises, getting the API key, is available even with the free tier. Using the API key, on the other hand, and does require a credit card that sets a minimum of $5. And you can put a threshold, say do not spend more than, don't go past 7, or update it every month, or just stop there. I've been doing these labs for quite a few weeks, and it barely got to $1, but the $5 was spoken. So there's that. Cost per task, API tokens, the compute. Example, keep cost under 2 cents per resolved ticket. Track monthly cost against target. It is around that. 2 cents per resolved ticket. Under. Simple evaluation plan. Make a tiny test set. 20 to 50 real examples with the correct answers. Run the agent offline on that set. Then they record the accuracy, the time, errors, and the cost. Try a small live pilot. For example, 5 to 10% of traffic. Watch the same numbers, accuracy, time, errors, and cost. Set alert times. Accuracy is less than 85%. Latency greater than 3 seconds. Cost should be greater than target. So those are these thresholds we need to set as we go on, and we see how the system responds. That's where the investigation part comes in. Watch for drift, perhaps weekly. If scores drop, update data, prompts, or tools, and retest it. Let's talk about drift a little bit. What it is, the world changes, your test scores quietly slip. The fix, compare today's scores to last week's. When they dip, refresh the docs, adjust the prompts, or retrain. Example, shipping carrier names change. Retrieval does get worse at that time. You refresh the knowledge base and accuracy bounces right back. Drift is also a big concern with the fairness of a model that actually happens to drift also. What we do is we use something called the Lime algorithm. It perturbs the values in each column. If the salary, for example, in a column is 100,000, it says, what if it was 70,000? What if it was 130,000? Would this person still be able to pay their loan back? The Lime algorithm does that. It perturbs the values. And so it calculates the drift as to and predicts at what point, for example, the bank might become cautious of lending money to a certain person. And of course, there are hyperparameter adjustments and feature engineering, which you take many columns. It's not just one column. It's not just age or gender or salary. Maybe there are many other factors. Changing your apartment constantly. For a bank, that's a reason of concern. So one uses the drift measure. The bottom line, use a small set of clear metrics: accuracy, speed, reliability, adaptability, cost. Track them regularly and retract when they slip. That's how you keep an agent useful over time, not just for one day. So how are agents judged? Huge, huge topic. As we It's over here. As we refine metrics, it's also essential to consider who or what judges agent performance. LLMs as a judge, so that could be one. Quick but surface level evaluation based on pattern recognition. Useful for initial checks, but they miss subtle domain specific nuances. Agent as a judge. Agents can evaluate each other using iterative, context-aware reasoning. This approach supports dynamic optimization and helps identify root causes of performance issues. Human as a judge. Involving human expertise adds depth, ethical oversight, contextual interpretations. While not scalable for all tasks, human judgment ensures that AI-driven decisions align with business values and regulatory standards. You know what I think about judgment between human and machine? Uh, our judgment might be biased implicitly. The machines might be biased explicitly. Implicitly, it's I'm not even aware of it. see somebody walking down our neighborhood in here with a hoodie on and pants almost falling off, and just got a backpack and can't see the face. Who is this? I know this neighborhood, right? Got concerned. In fact, that happened once, and I did follow them. They were a student at Brandeis over here. But my implicit bias took it. Explicit, the machine doesn't have much of that. It just describes individual with a hoodie walking down the street. Explicit bias, on the other hand, is something that inadvertently we might put in our data, and the machine could start becoming biased because of us, the input that we put in. Very interesting, that distinction. Combining these judging methods can balance automation efficiency with the depth of human intuition. Key lessons for the future: measure what matters. Pick 2 or 3 metrics tied to the goal. Set a threshold. Move humans up the stack. Let the agents do repeatable steps. People handle the review, the policy, the ethics. Define success first. Write clear targets and exit criteria for pilots before you build them. Run a steady improvement loop. Test, compare, fix your data, your prompts, your tools. Retest, maybe weekly. Watch for that drift. Automate with guardrails. Route high risk or low confidence cases to humans. Log decisions and audit. That's a huge concern, especially with cybersecurity. You can have a rules-based security in place, and that always changes. Should the machine just stop everything from this IP address? Should it inform us first and then stop it? Or just should it inform the entity that I stopped you from getting, or maybe do it silently? It all matters. Mini checklist: goals, metrics, targets, pilot, and monitor and iterate. This, my dears, is topic for our next discussion. I will see you soon as we talk about the use cases. Bye for now.